Good morning, and welcome to this morning's webinar on avoiding calling tech support and some of the top tech questions that we receive from dealers. This morning, what we're going to do is cover some of the most basic questions that we receive. My name is Jason Collins, and I am the supervisor for technical support. We'll start off by covering some of the most common requests that we get. One of them is our networking assistance, which covers network basics, internal networking, and external networking. We'll also cover camera challenges, DVR challenges, and how to get fast support from our technical support team. We'll begin by covering some networking basics. IP address is basically who you are to the world. There's two ways to look at an IP address. One is an internal IP, which is much like your local phone extension. Generally, those IP addresses will look like the following: 192.168, or start with 172.16, or start with 10. Whatever. It really depends on what your local networking scheme is going to be. You'll also have your external IP, which is your unique IP to the outside world. It's much like having an external phone number to the world. You also have a subnet mask, which is dialing local versus long distance. A default gateway, which is basically telling you, the operator, I would like to dial long distance. And then you have your DNS, which basically turns your most common names into numbers into names, much like your Yahoo and Google are turned into an IP address that can be recognized. An IP address, either an IPv4 or an IPv6, is a numerical value assigned to a computing device participating in a network similar to a serial number or a physical home address. An internal IP address is a numerical label assigned to each device, such as a computer or printer, also participating in a network that uses the Internet Protocol for communication. An IP address serves two principal functions: interface identification and location addressing. Class A addresses are IP addresses that are assigned to network devices such as computers and include all addresses in which the first bit of the first octet is set to 0. This includes all values from 00000001 to 0111111, or 1 to 127. For Class A networks, the first octet represents a network ID that is identified in the address by a subnet mask. Some examples of this are 10.1.1.1, 125.126.127.128, 5.5.5.5. Class B addresses are IP addresses that are assigned to a network devices such as computers and include all addresses in which the first two bits of the first octet are 10. This includes all values from 128 to 191. Some examples of this are 172 128.1.1.1, 128.129.130.131, 190.190.190.190. Class C addresses are addresses much like the others, but in this case, the first 3 bits of the first octet are set to 110. What this does, it includes all values from 192 to 223. Some examples of this are the more commonly seen 192.168.1.130, 195.196.197.198, or 200.200.200.200. Class C addresses are your more common addressing that you'll see in most residential areas, as those are generally the ones that are given to most consumer-based routers. A subnet mask is for subnetting to work. The router must be told which portion of the host ID should be used for the subnet network ID. Those IP addresses, bits that represent the network ID, are represented by a 1 in the mask, and those bits that represent the host ID appear as a 0 in the mask. Don't confuse a subnet mask with an IP address. A subnet mask doesn't represent any device or network on the internet. It's just a way of indicating which portion of an IP address should be used to determine the network ID. Below you see a chart which kind of explains that. Essentially, the last digit in your subnet mask will determine the number of hosts in which your network is able to communicate with. A default gateway is a device, such as a router, on a network that serves as an access point to another network or the internet. Some examples of this are 10.1.1.1.1, 172.1.1.1, or 192.168.1.1. Again, the 192 is going to be your most commonly seen gateway, as those are generally the ones that are used in most residential or consumer-based routers. A domain name service, or otherwise known as a DNS, stands for domain name service. DNS servers are maintained by Internet Service Providers, or ISPs. Google and many other companies involved with telecom and the Internet use DNS as a way to translate their physical or a web address. So what you see as google.com in your web browser is actually seen as an address such as 74.125.226.19. It's used as an easier way to remember an address other than a name. Names are generally easier to kind of keep track of than numbers. Next, we'll cover some common tools that we can use when on our network when we're actually networking the devices. The command prompt is a component of Windows It's used to input commands to launch a program or show characteristics. When you open a command prompt, it shows a black screen with white letters. The first line shows the version of your Windows. The second line is used to input command. If you type help at this prompt, you'll receive a list of commands that you're able to type in. Next, we have ipconfig. This is a common command to run, as well as ipconfig/all. What this does is when you're running this, it will actually reveal all the IP addresses which a system has obtained. So if you have two wireless connections on a laptop and you have both of those connected, by running an ipconfig/all, /all, it will actually show you each IP address that both of those connections have. This will help in determining which connection you're actually using in order to connect to your other devices. Another common ipconfig command to use is ipconfig/release. This helps in troubleshooting IP addresses if you come across a problem. It basically tells the system to quit using its current IP address and release it. So that IP address, that machine no longer has that IP address in its memory. An ipconfig renew is another good tool to use. This is generally used in conjunction with the previous tool of release. What this does is it basically tells the system to acquire a new IP address. This is similar to unplugging the Ethernet cable from your system and then plugging it back in. If you're unable to reach your system, this would be a good way to be able to tell it to receive an IP address. The ping and tracert commands provide a baseline for connecting to remote resources. Ping and the IP address asks, can I talk to this address and how fast is it? When you run this command, you'll receive either a reply, which means that you've successfully connected and received a reply from the device, or you'll receive a destination host unreachable, which means either there's nobody home or the device is not connected to the network that you're on, or the cable is disconnected, or there is an IP and addressing conflict. Tracert, or better known as traceroute, basically shows the full route to the destination IP along with the speed for each stop it makes. This is helpful when troubleshooting where potentially a problem lies within a network and where your communication between your system is failing at. This command is generally used on larger networks. It helps diagnose whether you have a bad router, bad switch, or a bad middle device, which is causing your communication to fail or communication to lag. So next we're going to cover getting your device on the local network. One of the first things you want to do is you're going to want to find an available IP address. In order to do this, you're going to use the tool ping, and you're going to want to ping an IP address on your network. By doing this, it will show you whether there is something on the other end of that IP address or not. If you receive a destination host unreachable message, you are likely have no other device on there, and that IP address is free to use. Another simpler method would be to set the device to DHCP, and that will find one for you. It's the fastest way to find an available IP. It also lets the router do the work for you. Make sure that you get a different IP from any other device on the network, but you must match your subnet masking gateway. You can confirm these settings by using the ipconfig command to obtain all your network settings. Once your settings, you find an available IP address, and your subnet masking gateway match the current network you're on, you should gain access via the local IP address for the device. Once this is confirmed, all devices on the local network can see this device. To make a device available from anywhere, what you're going to want to do is you're going to want to find your remote IP. This is commonly referred to as your wide area network or WAN address. It's also can be referred to as your external IP address. This can be obtained from sites such as yougetsignal.com, which will list the IP address that you're currently on up front. Log into your router. Once you obtain that address, you will need to log into your router. Some may require administrator rights. Most of them will require some form of username and password. Once you've obtained that and you've gained access to your router, you'll need to port forward each of the necessary ports for the device you're trying to reach from your external IP address. To do this, there's a very helpful site called portforward.com. This site will actually allow you to walk you through on how to port forward just about any device. Once you have those ports listed and forwarded in your router, you're going to want to test port forwarding. Once you've successfully tested port forwarding and made sure that those ports are open, that device will be accessible from anywhere in the world. You can use speedtest.net to test your bandwidth, your upload and download capacity to make sure that your current network availability will allow for the external access of this machine. Remember to use the WAN IP only from a remote location. If you're inside the network, you'll want to use your local IP address. If you're outside of the network, use your WAN IP. There's two types of IP addresses, dynamic and static. Dynamic IP addressing is where your WAN IP address changes. This is dependent upon the internet service provider. If you have a dynamic IP address, it means that you're sharing an IP address with several other customers. This does not mean that you're sharing the IP address at the same time. This just means that your IP address cycles from a list of IP addresses that the ISP has through its customers. Static IP addressing is where your WAN IP address remains the same and is also usually available for an additional cost from your ISP. Some of the more common networking pitfalls that we have are multiple routers in the network. We always recommend that you try to use the most outer router on your network. This means use the router that is most closest connected to your external connection, such as your modem or closest switch to the modem. We don't recommend using the fourth or fifth router in the mix if you do have one. What this causes is it causes port forwarding to be needed on more than one device. Devices on multiple networks. If you have devices on multiple networks, you'll want to engage a local IT resource as they may have specific needs in order to get that device on the network. Satellite internet services. Those have very low probability of success and are very high susceptibility to weather interference. We've had some success with satellite internet services. However, it is very much on a case-by-case basis. There's very low success probability that they'll work over a large span of time just because of the weather interference. And then a wireless IP. What you want to do if you're planning a wireless IP, make sure you plan before you program. What this does is it helps you keeping from running into interference or IP addressing problems. Some common camera challenges that we run into are ground loops. Those can be caused by mounting a camera directly to a metal surface, or EMI, or electromagnetic interference. Insufficient power, video but no IR, which also could also cause reduced camera life. So if you're running a camera a very long distance, it's generally very good to power the camera at the source. However, in some cases this is not possible. But if you do not provide sufficient power to the camera, you will not receive IR, or you will receive video but no IR. By doing this, you may also reduce the camera life. Dirty power, which is better known as power surges or a lightning strike, or equipment that runs in cycles on the same circuit. And waterproofing. This helps prevent corrosion to connections and helps keep Mother Nature out of sensitive components. Some common DVR challenges that we run into are the hard drives. The hard drives are the most common failure we run into, and they generally develop bad sectors due to constant writing. These failures are only often discovered when an incident is being looked for. What we recommend is that you test your system 4 times a year. What this does is it helps prevent important data loss, and it ensures the system is running optimal. Power surges or power outages. These are very hard on the hard drive. What we recommend in order to keep the stress off the hard drive from these situations is to use an uninterruptible power supply, or UPS. What this does is it provides backup power. It also helps protect against surges or sudden outages. A more larger scale would be a backup generator. What these do is they delay before they power on and provide extended time of backup power. In most cases, a lot of situations will garner either one or the other. However, the most optimum use would be based on your situation. Video resolution. Different monitors handle different resolutions. The output of the recorder may need to be adjusted based on the monitor that you have. DVRs often come set with basic settings. Motion and schedule recording are not active when shipped from us. Those will need to be set by you when you receive them. Next, we're going to discuss getting support fast. You can call directly into the dealer line at the number provided there, 866-659-3224. If possible, have your order information handy. This helps us in locating the devices, the correct devices that you're calling in about. And should you need or require an RMA, it will help assist us to get that taken care of for you quicker. Some of the troubleshooting tools that you may be asked for while on the phone with us is for a laptop computer, a voltmeter, ground loop isolators, an independent power supply, a portable monitor with a BNC connector, short BNC and Ethernet cables, a network switch, or team viewer. All of these tools will come in handy as we step through the process of determining what the problem is that you're having when calling. Listed here is my information. Again, my name is Jason Collins. I am the Technical Support Supervisor. My direct line is shown there, as well as my extension number should you dial into the main phone line. My email address is listed there should you have any questions or need any further assistance. At this time, I'll begin taking any questions that you have on any of the items that we've covered or any other questions that you have. Okay, if there are no further questions, if there are no questions this morning, I definitely appreciate you tuning in to this webinar. Again, if you should have any questions, please feel free to reach out to me or your sales representative, and they will get them answered. Should you require or would like a copy of this webinar, please feel free to email your sales representative as well. That will be provided for you. Okay. This concludes this morning's webinar. Excuse me. Thank you for tuning in, and have a wonderful day. Thank you. Bye-bye.